let's have a look at how SolidWorks and SolidCAM can work hand in hand to make programming a sliding head lathe as simple as possible. From making toolpaths, to then going and transferring material from one spindle to another, and then finally synchronizing operations to make sure the machine is running as efficiently as possible. SolidCAM is embedded directly inside SolidWorks, so using a drag and drop template on the face here to do a face turning operation is super simple and super quick. We can see we use the direct model in itself to program from, and we can use the template to give us any of the intelligence we need. And we can see as we simulate there, we cut that face. From there we can use a template again and drag and drop in onto the CAM manager. I can choose faces that I wish. In Swiss turning or sliding head machining, you can do sections at a time. We want to work close to the guide bush at all times to make sure the part's got as much rigidity as possible. We've done that just by using a section. We can see here we get the intended results by checking in the updated stock. From there we can also go assign the groove that is there present in the part. We can see with the use of the templates, whether it for be turning or grooving, that you get great repeatability, whether this be for yourself on multiple parts or between your colleagues as well. So make sure that you have one best method all the time. After picking the face there, we can see now as we go and save and calculate, that grooving operation will be available for us to simulate. With the turning simulation open, we can see first of all that turning toolpath that goes and cuts nicely, and then the grooving to follow suit, and we keep to the size of the part we want to machine. If I want to replicate those toolpaths, I don't have to go and start them from scratch. You can use Ctrl-C on your keyboard or copy and paste in the tree, and we can then just go and simply assign those new faces to work between. As you can see I'm doing now the first turning operation. This again makes sure that as you go through cutting the part, making sure we're making the most out of what the sliding head lathe is capable of with the rigidity of the guide bush, and we're keeping consistency as our approach is the same every time because we're using the same toolpaths over and over again. Again, you can see this allows us to build up what could be potentially a more complex model very quickly. Again, let's review what we've done. Instead of simulating, we can check the updated stock. We can see what we've planned to do is what we get as an end result. And again, I can copy and paste for that one last section on this hydraulic fitting to both turn and groove. The only difference with this being, obviously, we've got the abutment at the end that we don't want to come at 45 degrees to. So we can see how that interacts and gets us the shape we want. And then obviously the smaller groove to make sure we cut that as well. Let's keep going with this part then. We can actually see we've done turning operations, but there's a few things that we've missed out. We may have wanted to do the drilling in the centre ball, and we'd probably want to do that immediately after the facing. So we can see I've highlighted the first facing operation in the tree, and then created the drilling operation. This allows me to position the toolpath in between currently used operations. You could also drag and drop just like you can do in SolidWorks, but gives us a really good way of manipulating what we want to do and when we want to do it. Again, making most of SolidWorks features by using the section view, we can see we get where we want to be. Reviewing the toolpath without looking at the simulation, we can see the retract goes both back in X and Z. I don't want this, so I've changed that just to Z only. Obviously for turning, you could change that to X only if you wished. And let's review that in the turning. We can see we get a perfectly drilled hole, exactly how we need it to be. It might not just be the drilling we want to add in. We can also add milling operations or anything else for that matter. And actually I want to hit these two flats that we can see here. I'm going to go and quickly pick those faces so we can go and machine them. We can see the pink and yellow denoting what is a wall and what is an open edge. We can go and select the tool directly from the machine preview. Really handy, especially when you've got a fully kitted out machine. You can just go and highlight the exact part or tool that you want. And you can confirm, say, upper and lower levels. We can see with green, they've become associative to the SolidWorks model themselves. So if the design changed, they would change as well. I can also do a rotation to hit the underside at the same time using the 4th axis. We can keep those toolpaths linked to one another. Again, verifying that through simulation, we can see that rotation happening nice and simply for us, and the milling of those flats are complete now. The final operation I want to add in here is the actual drilled hole across the flat. We can do that with another great tool inside SolidCAM, which is just in the milling drilling command. We've got a round 4th axis. We can pick that and pick a face where the hole is, or pick the hole itself. Select a tool like we have done. Say for sliding head machines, the machine preview is an excellent option for this. We can find exactly what we wanted to do, and then go and find the upper and the lower level of the drill. At the same time, we could have also gone and changed the technology depending on how we want to drill. Maybe potentially want to peck it this time. You can see as well I highlighted the drill depth by the bore. We can do this because we're working around that 4th axis, remember. And the save and calculate will give us a similar result, and like before, we can go and generate ourselves an option where we can rotate around the 4th axis to give 2 toolpaths, making sure that everything that's been asked of us on the part has been machined. The next big section to work on is transferring the material. We want to go from the main spindle and start working on the back spindle. Machine control operations in SolidCAM make this a breeze. We can go and select these as cycles. You can see there's plenty that could be done in this star. We can go and pick, in this instance, the cutoff tool we want to use. We can position how far out we want the material when we do the cutoff. And you can see I've got a full machine preview to change to anything I need to at any point in time. You may want to go and change this back to 43mm. We can see the update happens live. We can go and save that for use. After that, I can also go and bring in the back spindle and choose exactly where that wants to go. It flags if it needs to change from different channels or turrets and does all the hard work for you. We can see everything's been kept from the last machine control operation, and I can use the graphics area in the machine preview to get exactly where I want to be for the final clamping of the back spindle. Super handy and super useful. With this, we could go and verify this in machine simulation, but for now we're just going to go and straight away add the cutoff at the back. This can again be done from a template. You don't have to do those simple tasks over and over again with long button clicks. Just simply go and get the geometry that you want to define. We can see here, pick that back face, but you can also pick SolidWorks sketches if you want to, or indeed the wireframe of the model. We can go and make sure we can do any modifications if that's what we want to do, and then go save and calculate, ready to work on the back spindle. By reviewing the updated stock, we can see the cutoffs worked as intended, and we can then go swiftly on to using back spindle retract. This goes and puts the machine in a position where we can start using the Y2 tools to use for the facing, which we can take from a template yet again. We can also in that template choose a new coordinate system, Mach 2 in this case, pick the face, and then it'll do the rest for us, even changing the tool to X- because that's what's required because of where the tool sat in the machine in this instance. We can then also go and get our milling operations. We're going to use pocket. I'm going to use outside feature recognition to go and machine everything that's needed on that hex. Like previously, just because it's on a different turret doesn't mean that we can't use the machine preview to select the tool. And I just may want to edit the depth because I don't want to go the whole depth, just the 6mm. And we can actually add a delta in there to make sure we break through completely. All the options that you're used to in milling are there, including polar, which is exactly what we need in this case. Again, we can save and calculate, and a toolpath is made for us. Moving on to the engraving, we can go and select the geometry. You can see in this case the tightening is left-handed because of how this hydraulic fitting is needed, so this engraving is really important. Using multi-chain allows us to pick multiple edges quickly at once. We can go and get the machine preview to get the chamfer mill that's going to do our engraving, and then we can pick that we want to use the technology on the center line to cut the engraving operation and do it 0.1 deep, making sure it's just deep enough so it's legible. But again, with a save and calculate, the toolpath is there available, and we could go and simulate it or use it in another operation. But now let's continue with channel synchronization. This is how we can make two parts of the machine work together as one simultaneously. We can see here we've taken out the weight codes in blue, and we've gone and added another workpiece so we can work on left and right side. SolidCAM does the rest and synchronizes them together, and we can check what happens in the machine simulation. We can see as we work through, everything on the sub spindle and Y2 works at once, as well as the main spindle and the main turrets working in synchronicity, making sure that you get your part done as quickly as you can. With the simulation completing and giving us the part we want,